It is very likely on the real exam that you're going to see a very big molecule. And there's nothing that examiners like more than to put a big molecule on an exam to make students anxious. But you just have to use the basic rules that you've learned and try to apply them. So the question is, how many chiral carbons are there in this molecule? Just as a backdrop, only backdrop, nothing that you need to know. You need to be able to get how many chiral molecules are out of a molecule like this, that's for sure. But just as a backdrop, this happens to be vitamin B12. It happens to be most of vitamin B12. This is called the corrin frame. In the center, there's a cobalt atom, cobalt cation, actually, positively charged. And these are nitrogens around here, and there's this frame here. And actually, the molecule continues below, but that's not relevant to what we're looking at. So all I'm asking is, within what you can see, how many times can you locate a carbon that is bonded to 4 different substituents? So really, on an exam, you should be able to count those carbons in basically 1 minute. So, but take the time that you want, freeze the frame, pause, whatever, and try to locate how many chiral carbons that you can count. Then we'll do it together. Okay, so we're going to locate the number of chiral carbons. I'm not worried about down here. There's a CH3 way down here in the corner. I see a little bit of a double bond, some nitrogen, oxygen here. That's not chiral. I'm looking for carbons bonded to 4 different things. Here's a carbon bonded to carbon which is CH2, so it's bonded to hydrogen twice. I ignore that. I ignore carbon bonded to oxygen twice. I ignore that. It can't be bonded to 4 different things. Ignore. So in fact, all the branches I just ignore, because there are all these. There's methyl groups, carbon bonded to hydrogen 3 times. There's CH2. I ignore all those groups. And then there's these groups where carbon is bonded to oxygen and then nitrogen on the other side. So that means that carbon is double bonded to oxygen with a carbon on one side and nitrogen. Because it's double bonded to that oxygen, it must be, because carbon has to be bonded 4 times. That means that these are not chiral either. And in fact, these are called amides, which we'll discuss much later. But it's not important. The point is that it's not carbon bonded to 4 different things. So now I'm going to start going around the ring. Okay, because I know there's nothing chiral inside. There's nothing chiral that's branched to it. So I'm going to start moving around the ring and looking for carbons that may be bonded to 4 different substituents. Over here, at the carbon located here, it's double bonded to nitrogen. So that carbon cannot be bonded to 4 different things because it's double bonded to something. Then I look at this carbon over here. Oh, I've got a possibility here. It's bonded to one thing over here with a double bond over there, CH2CH over there, and it must be a hydrogen that it's bonded to that's not showing. This is bonded to 4 different substituents. I know some students are thinking, but isn't this the same as this? No, it's not, because if you go here, this is bonded to 2 CH3 groups. This is bonded to a double bond and a nitrogen. And I know you might wonder, where do you stop if you start going around? You never stop, is what I said before. You always look to see if there's a difference, and clearly there's a difference at the first carbon. So that's our first chiral carbon. I'll put a little arrow here so that we never forget this beautiful little chiral carbon. And so we go up here to the next carbon. It's bonded to 2 methyl groups. That's the same thing twice. So it's not chiral. Then this carbon up here, double bonded, cannot be chiral. This one is double bonded, cannot be chiral. This one, double bonded, cannot be chiral. And then this one, oh, we got a possibility here. We've got CH2, all that. We have a hydrogen, which is not showing. Then we have this down here with this double bond, and then we have this up here, which only single bond, and plus there's this CH. There's lots of differences. So this is a chiral carbon right there. I'll just put a little arrow there pointing to that chiral carbon. And we continue to go around. Oh, this has the same situation. CH3, ethyl group up here. So two different things. Then this is clearly different from this. This has a single bond and a single bond. This has a single bond and a double bond. It's different for many different reasons. So then that's another chiral carbon right there. So far we've located 3 chiral carbons on the right side of the molecule. Now we're going to start moving over to the other side. So here's a carbon here, double bonded, so it's not chiral, not chiral. And then over here, carbon is double bonded here to nitrogen, not chiral. Then we have here, oh, what do we have? We have a group up here. We have a hydrogen, which is not showing. Then we have this, which is clearly different from that. So that's a chiral carbon over there. That's our first chiral carbon on the other side. And then we come down here to the next carbon. Oh, look, CH3, this whole other group. That's 2 different groups. This is different from that. So we have a chiral carbon right there. And then we come down to the next carbon. And this one has CH3, something else. Then it has this group over here with a nitrogen down below, a group over here without the nitrogen above. So this is a chiral carbon. And I'll just put something over here. So, and we go to the next carbon, has a hydrogen that's not showing. It's bonded to a nitrogen. It's bonded to this stuff down here and this stuff up there, different. So that's another chiral carbon right there. And then we go over to the next carbon over. This one's hydrogen not showing. This group showing. This over there and that over there, completely different. So that's a chiral carbon. And then coming down here, we have this carbon is bonded to all that. And CH3 here is bonded to this, which has a double bond. It's bonded to that, which doesn't have a double bond. No, all single bonds up there. So this, therefore, is also a chiral carbon right down there. So what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 chiral carbons.